Good day, guys. Hope you're all doing so well. Let's answer this question too. And it says that you must state the Newton's second law in motion for 2 marks. Let's just define it, guys. Ibo. So here's my Newton's second law. Here's it. It says that when a resultant or net force acts on an object, the object will accelerate in the direction of the force at an acceleration directly proportional to the force and inversely proportional to the mass of the object. Now, guys, 2.2 says that you must draw a labeled free body diagram of all forces acting on the 22 kg block for 4 marks. Block is acting on an incline, or if any block, if this block is on an inclined position, therefore we know that we have got force that is going downwards all the time, and this force is F parallel. It is always going downwards, irrespective of in which direction is our block heading to, but our F parallel is always going downwards. Now remember, this block right now is going up, okay? Therefore we have a frictional force, okay? Our frictional force, our frictional force, let me just extend this line here, and we've got our frictional force here, okay? Now, guys. So yeah, our block is going upward, therefore our friction opposes the motion, but our F parallel it just goes down because it's gravity. Yes, let's draw our proper free body diagram. We know if we have an inclined position, our normal force is in this direction. In most cases, this is our normal force. We've got our weight here, Fg, which is our weight. Then downwards there, we've got two forces. We have frictional force and our F parallel. Then remember, we have a tension here. Our tension is going upward. Therefore, this is our force tension, F tension here. Is going upward, Ft. They will mark it in the examination. So it's 4 marks. 1, 2, 3, then 4. Sometimes you don't need to involve F parallel, but for your own sake of answering questions, you need to involve it, so they can understand how to answer questions when they ask about finding whatever. Then 2.3, they're saying a constant force of 43,86. So now we have a constant frictional force of 43,86. Constant frictional force that is equals to 43,86 newtons on the 22 kg block. Since on this block there is frictional force, this frictional force has gotten a value right now, of 43,86. Calculate the magnitude of the angle theta that will keep the system moving at constant velocity. At constant velocity. Constant velocity, remember, it means that theta, this angle here. Now, how do you find theta? We know that F parallel acts parallel to the surface. So we're going to use sine theta component. Then that means our theta will be found from our F parallel only. So let us use our free body diagram to answer this question. Now, we're going to plot whatever that is in our free body diagram here. Guys, we're going to plot it right here. So now you know F net is equals to 0, because of what? The constant velocity. Our constant velocity is it means that our acceleration is equal to 0. Therefore F net is equals to ma. Where I see a, I put in 0. It will be 0 times m. Then it's going to be 0 here. Hence it's like this. It's like F net being equal to ma. Then I put 0 on a, and a is going to be 0 times equals to 0. So it's the same. Yes. Let us use our free body diagram to answer the question here, guys. Now let us answer the question. Now, our theta here. So our theta, we want to find it. F net writing the Fnet. So it's going to be tension, and tension, and our block is going upward, therefore we'll choose upward as positive, and up as positive. So tension minus frictional force minus F parallel, and those are three forces acting on the block. Here, tension minus F parallel minus frictional force is equals to 0. I hope you guys can see it. Then now we don't have the value of tension here. We don't have the value of our tension. So this is for the 22 kg block. 22 kg block. Let me just see what can I find tension with our 15 kg block now. So we have our 15 kg block here. So it's going to be F net is equals to MA. I don't have my tension, so I need to check am I going to use simultaneous equation, or I might find my tension when I use my 15 kg. Since my 15 kg block is just a block on an interstitial thing on the string. It's just this block that is on a free fall. That is not on an incline. So let me just draw the free body diagram of our 15 kg block, and just it's going to be like this. 15 kg block. We're going to have our tension force here and our weight here. So it's going to be tension minus weight is equals to 0. So tension minus, what is our weight? Mg. And weight I want to mass times gravity. And what's equal to 15 multiplied by 9.8 is equals to 0. So if I put this on a calculator, 15 times 9.80 is going to give me 147. Then this equal to tension minus 147. Then it's going to be, I'm going to transpose this negative 147 to the right. It's going to be positive 147 newtons. Therefore, now I have the value of my tension. Therefore, there's going to be no need for me to go through the process of simultaneous equation. And I have my tension that is equal to 147. So I'm gonna to the right, and it's going to be negative 1 over 3. Equal to negative. Therefore, I'm going to say 22 times 9.8 tip guy. 22 times 9.8 tip guy. 215,6 sine theta. Remember, this negative is going to come down here, and I'm going to transpose this 103 to the right. Equal to negative 103. Therefore, my sine theta is equals to, I'm going to divide both sides by negative 215,6. If I divide both sides by negative 215,6, I'm going to get so here is 103,14, not 103 only. So it's 103,14. Sorry guys, apologies. Yes, so if I divide both sides by negative 2156,6 is going to give me 0,478. And then now I'm going to say theta is equals to, remember to remove this sign, I'm going to introduce the inverse second function on the calculated second function. And then a second function sine, you just say second function there on the calculator and sine 0,478. Then the value of our theta is equals to 28,58 degrees. I hope you can literally hear me, guys. This is how you simplify this problem. Let us go to the next problem. Now 2.4.1. 2.4.1, it says that so if you guys can read the statement, after you've read the statement 2.4.1, it says go to, remember the last statement for 2.4 said to us that, remember the last statement on 2.4 said to us that if on the last part it says go to the kinetic frictional force acting on the 22 kg block while it accelerates downwards remains the same. That means while this 22 kg block accelerates downwards, while this 22 kg block accelerates downwards, okay, now right now, remember previously it was going upwards, right now it's going downwards. While this 22 kg block goes downwards, our kinetic frictional force, which is now going upwards, remains the same. That's key. That's very important. Now 2.4.1, explain why the kinetic frictional force will remain the same even though the system accelerates. Why? 2.4.1 why will the kinetic frictional force remains the same even though the system accelerates? Because of what? Remember, the kinetic frictional force depends on the angle theta on an inclined position. This is the answer for. You must remember that kinetic frictional force only depends on the angle theta. You must remember that going forward, guys. Ne? Yes. 2.4.2, calculate the acceleration after the system, or calculate the acceleration of the system of blocks. That means you need to calculate the acceleration of the two blocks. Obviously, it's going to be one acceleration here. So now I'm going to introduce F net here. F net is equals to ma. Now they do not tell us velocity is constant. That means you need to find a. You need to find the acceleration is a here. Now let us start with our simple one, the 15 kg block. 15 kg block. Now, if we can check from the diagram, guys, there is this force here. It means our 15 kg block is going upward. That means there's this force included here. Remember, the statement says that if a force of 2.4, remember 2.4 said that if a force of 172 newtons, they're saying if a force of 172 newtons is applied on the 22 kg block and the system of block accelerates down the slope. So this force is being shown on this 15 kg block. It means this force applies on both the blocks. If they show you on the 50 kg block, it means this force 172 applies on both the blocks, not only the 22 kg block. Ne? Yes, guys. So now I'm going to draw all the forces included in this thing. Ne? Yeah. Let me just do that. So now let me just say F net. F net is equals to ma on the 50 kg block. So you have this force that is included, that is going upward. This force this force guys, it's very important to put it. This force plus our tension force minus obviously our Fg. Remember, our block is going up. So you want to choose upward as positive. So now on the 15 kg block. So now our Fg is our gravity is going down all the time. What's the value of our force? 172. What's the value of our tension? We don't have the value of our tension. Tension. Remember, we are now in 2.4 and we're only given the force of 172. Tension right now. Minus what is the value of our Fg? Mg. Mg on a guy 147. 147 is equals to 15a. Then 172 minus 147 guy 25 plus tension is equals to 15a. Therefore, my tension is equals to 15a minus 25. This is my equation number 1. I hope we can literally see it. Then now I'm coming to the 22 kg block. 22 kg block. And here F net is equals to ma. So now what are forces acting on the 22 kg block? Remember, Our block is going downwards, so our block is now going downwards. Therefore, sorry for throwing this bad, guys. We have a force here and force of parallel, and remember there's another force that is included there. We have the tension, our tension is here. Ft, another tension. We have our friction, and our F tension. So there are 1, 2, 3 forces acting on a 22 kg block. Our block is going downwards. Always the first parallel is always going downwards. All the time, guys. First parallel is always going downwards. Let's come back here now and substitute. Force force plus F parallel. FG parallel is not a problem. Obviously, these two, they are opposing the motion. Frictional force minus frictional force minus tension force. Tension force is going upwards. Tension is so it is equals to 22A. What is the value for our force? 172 plus FG parallel, it will be mg sin theta. What is the value for our frictional force? Is 43,86 minus tension is equals to 22 times A. Then now, then after we are done with that, 172 plus mg mass number 22 times 9.8 times sine 28,58 minus 43,86 minus tension is equal to 22A. So now I'm going to put, remember, both masses it still works. I'm going to put the whole thing here on the calculator. And if I put that on my calculator, let me just put it as speed guys. Apologies. So I'm gonna say 170 plus bracket 22 times 9.8 times sine 28,58 closed bracket. The answer there is 275,13988 minus 43,86 minus tension is equals to 22A. Then I'm going to minus the 2. So I'm going to say the answer minus 43,86. This thing minus this. Apologies. Yeah. 43,86. Get 231,279. Etc. is equals to so I'm going to take my it's not equals to, guys, so apologies. So it's 231,279 minus tension is equals to 2A. Therefore I'm going to transpose, so I need to be left with tension on one side. So I'm going to say I'm going to take this 2A to the left and take out my tension to the right. So that I'm going to have tension is equals to 231,279 minus 2A. This is my equation number 2. So I took my tension to the right and my 2A to the left, so that I can be left with tension on one side, L1. So I'm going to substitute. So I'm going to equate equation number 1 and equation number 2. The tension is equal to this on my equation number 2, and my tension on my equation number is equal to this. So I'm going to equate the 2 and find the value of A. But that's very simple. 15A minus 25. Equation number 1 is equals to 231,2798 minus 22A. So I'm going to solve for A. So 15 plus 22, keep guy, 37 37A is equals to, then it go 231 plus 25. 231 plus 25 tip guy. 256 comma 2798. Then I'm going to divide both sides by 37. Therefore the value of A is equals to 6,993 meters. So apologies guys. A is equals to 6,93 meters per second squared. This is the value of our acceleration. Thank you very much guys for having to enjoy this class. Let us meet in the next session. Thank you very much.